to about 4 or 5 stages since 1950s. Our great leader, former leader, Chairman Mao, who is much interested in the biogas at that initial stage. But of course, due to the lack of science and technology, so it stopped for some years. Then, up to 1970s, our former President Deng Xiaoping also paid a visit to some rural areas due to the energy crisis in 1970s. And then up to 1980s or 90s, our next generation, Zhang Mi, also paid much attention to this. And then the next successor, Fu Jintao, also gave much attention to biogas for rural areas. Until now, the new president, Xi Jinping, is also very bad picture, is not here, sorry. Next, we highlight of some South-South cooperation in biogas fields. South-South cooperation is biogas among developing countries, the China, Thailand, like this, or China, Africa. So under the TCTC principle, funded by Chinese government, local governments, and the UNDP, FAO, ADB, and other international organizations, as well as some NGOs, some Sino-Africa or Sino-Thailand biogas cooperative programs have been carried out in different ways, both in China and many other countries since the 1980s. Some patterns of cooperation. What kind of cooperation we have undertaken in the past decades? One is conducting some biogas training programs in China and some African countries or Asia countries. Secondly, to build some demonstration biogas plants in local Africa or Asian countries. Third, to provide biogas consulting services, also exporting experts and equipment, and holding some workshops, start tours and exhibitions, like what we have doing this time. Some major fields in biogas technology application. Generally speaking, what the activities of biogas cooperating projects in the following 3 or 4 major fields. First is for rural household biogas digesters. Second is for large and medium-sized biogas plants at animal farms. Third is for industrial biogas plants for wastewater treatment. Or also for decentralized wastewater treatment system, that is DWAS. You know, DWAS is mainly for the domestic wastewater treatment, which is not centralized, treated in centralized way, pipeline way, but treated in the individual on-site way. That is, which is non-energy consumption, no management, and but also for domestic waste, which we can get in anaerobic and aerobic treatment at the same time. And also for comprehensive utilization of biogas, bioelectricity, and bioslurry. That is, through biogas system, we can get some results for biogas use. And the biogas could be used for turning in producing electricity and also for bioslurry used for fertilizer and biosludge. So that is very comprehensive. The benefits of biogas comes from the comprehensive utilization of biogas and bioslurry. I remember in 2006, I was invited to be at the international workshop in Bangkok by SMV with all Asian member countries. That is, the topic is the bioslurry application in biogas system. So I present the country's report of bioslurry comprehensive utilization. That is some pictures which we have conducted in China and some other countries. This picture shows the first training course I was sent by United Nations FAO, and also this is the training in China in Biogas Institute of the Ministry of Agriculture. Because I was given the training. That was a training I was giving the lecture in Rwanda, and some technicians are working in some African countries. But I remember the first time I came to Thailand, that was in 1985. We worked for about 3 weeks in Bangkok with the energy. The Ministry of Energy, and we conducted some training there. So sorry, picture's not here. So that is the first time. So Thailand could be my second hometown since I came here again and again. Also, some activities we have conducted in some other developing countries like Tunisia. The first, for example, the first demonstration plant we built, that is a Chinese government donation project with a chicken farm. This plant was built in 1999 and was put into operation in 2000, and until now it's working very well. And second project we have done in Tunisia, also requested by the Tunisian government. We set up a national biogas lab, and all this equipment for laboratory was sent from China to Tunisia. So, and some professors came for the training in Tunisia. And also we have done some national feasibility study and the biogas potential study and strategic study, and making the potential and the development strategy in Tunisia. So that is one of our activities. And another is we gave also some design for in Botswana, so different African and Asian countries. This is another system we have done for DWAT system. This was in Rwanda. We did some work there. You see, this is a university compound. Before building the system, here, this compound, when you enter this campus, everywhere you smell very badly because of the sewage flows everywhere. So this principal of the university complained too much. So he urgently requested us to build, to find a solution. Then I say, it's okay, we can build one plant for you. Then it solves the problem for domestic sewage. Originally, it was planned for treatment of 300 students' wastewater, but actually it solves more than 400 students from their sewage of students' dormitory. Then came our ambassador and the Minister of Foreign Affairs came to see, because not only because of the sanitation and the environment, it looks nice, give a good look, but on the other hand, it gives lighting and the fuel for lighting and cooking in the students' dining hall. Here, this is a dining hall for the students. Then, because there, even up to now, some electricity, the short of electricity. In the evening, students came to enjoy the light from a biogas. That is the big plant we have built. One is in Tunisia, another is in Tanzania. Also, we can give some case study here, like the land. It's a wasteland. We choose a private farm, animal farm, and plantation. So the land take is 1,200 square meter, and the main tank is 300 cubic meter. And the process we take is a complete mixing plus AF, the anaerobic filter. So without a heating system. But in summer, it's too much gas. Even they cannot use all, then release some gas. The floating gas filter, sorry, here it should be 100 cubic meter. There's a small mistake. And HRT is 20 days. And gas production is designed for 200 cubic meter per day. But actually, sometimes in summer you can get about 250. And power generation is about 300 kilowatt hour per day. A comprehensive use of biogas, bioslurry, and bioelectricity with energy, environment, and agriculture and economic benefits. That is a model for this plant. In this model, for example, if you, in your factory, first you want to build or design a biogas plant, you should have a model, not only the drawing for designing, also for some model for demonstrate. This was, for example, this is the front gate. This is in the farm. This is the side gate. Then the slurry comes this way to the pretreatment tank. Then going to the pumping house. Then it gives, from pumping house, it goes the slurry, fresh chicken manure, mixed with some water in some proper concentration. Then it gives gas here from the main tank. In this main tank, at that time, it was built with concrete. And inside, we put some filter, so it can absorb many bacteria, methane bacteria, so which gives more gas. The yellow line is the gas, which is collected in the floating gas holder. Then the gas is supplied to the generator house. So from the generator house, part of the electricity is used for the biogas station for pumping or for some other pumping. Then the other electricity goes to the farm for other machinery or chicken house use. So that is the model which is used for national exhibition, for environment, or for renewable energy. exhibition or for agriculture exhibition. Because this is a greenhouse, then the bioscenery is used everywhere in this farm. That is the picture for construction. Also, a picture for the site training for Tunisian worker. These are the mass workers, but they could not understand Chinese, of course. Then we have only a French interpreter from French, Chinese into French, and from French into Arabic, and from Arabic to the technical Arabic. This is the format. So there are 4 teachers standing here. I took this picture because I found it very interesting. That is the fellow before, after completion. From the gate, we can see this is the real demonstration. After using the bioscenery and the bioscenery, so these people are this is our Chinese engineer, and these are local technicians. They are happy with because of the use of bioscenery mixed with the soil. Because this area only 3 kilometers away from the Sea of Mediterranean, so the soil is very salt. But after mixing with the bioscenery and sludge, then the quality of the soil becomes much better. And this is a tree of olive tree. Olive seeds, the quality and the production is about more than 10 to 15% increase. And the mature time is 1 month ahead of the normal. So they are happy with this. The farm owner is very happy with such benefits for agriculture as well. So that is some analysis and the operating cost, and also for the benefits of the project. So this, we can see the biomanure. This is the energy benefit. This is the biomanure benefit for agriculture. So biogas could be multifunctional for energy, for agriculture, and for sanitation and environment. So that is why government and people are now much aware of the biogas. You see, it is not, even in this time in Africa, many government officials, even the governor, say it is not an alternative, but it is a must for our government to start to build biogas system. It is a must, but not an alternative, but a must. So they realize the importance of biogas technology, and also some social and environmental benefits. Also another case study is a DWAT system. We can see DWAT for treatment of domestic wastewater. So like this, you can, because if we compare with the site, before building the biogas system, they dig a lot of channel and needing and the wheel also they don't have space to hold the sewage. Then the sewage comes everywhere in this small hilly area in this campus. So students and the teachers all complain about this. Then after this, it solved this problem. So after built, the International Red Cross and they came to evaluate also. This is a construction underway. Some benefits for this plant also. The cost study and the operation cost. So, and you see this operational stuff is zero, energy cost is zero, and maintenance only some regular withdrawal of biosludge every 3 or 4 years, and some benefits from environment give a very radical change, and the sanitation very satisfied by the beneficiary, and energy biogas brings happiness to the kitchen and the students due to the fuel and lighting. So this is a very successful case as well. Then we come to the domestic biogas plants, which we have done in some Asian or the developing countries. For this, we have conducted one contract with the Ministry of Infrastructure in Rwanda, and this directed after the first demonstration project with government to government. Then the Chinese enterprises, that is the CNCC Sichuan, has signed that I, on behalf of this company, signed the contract directed with the Minister of Infrastructure in charge of energy. So we give supply and install of a fiberglass biogas plant at some selected village with success, and training for different kinds of personnel, from management staff, technicians, and users, even housewomen. For this, it's a handmade, but at that stage, it is the earlier time. Later on, I will introduce the updated technology and the products, that is home ship products, which is much more advanced. But actually, at that time, it gets success. This is for the first plant for transport. Some key parameters for this different, you see, this is the volume for different size of this plant. Normally we take 6 cubic meter. This is the diameter at that time, but now and then this is the weight, and this is the feedstock which are going to use. This is the lifespan, more than 20 years without maintenance. We see under construction with because the plant could be designed in different, according to the size, maybe in a straight way or maybe in a lot way, according to the size. You see this plant here, in the triangle way, still it works. This is for assembly on site. This is some TV reporters. We are conducting the local training for the local users. And this is the Minister of Energy to inspect the site. You see, I took the same dress and the benefits. At that time, the USD is much higher. So now we can say that the plant for 6 cubic meter is around more than $500 due to some inflation and the rate against the US. Like the Thai baht is getting higher than US dollar. Other benefits, operation cost is low, and the maintenance is not only after 2 or 3 years, you take out some starch from the bottom. So this is the energy benefit for cooking and lighting. And the fertilizer is the crop yield and the quality increased also by 10 to 15% increase. Environmental sanitation also great changes, with some delays occurring much reduced down. So farmer, the users benefited a lot. So this time, the Rwanda government, after when we had a meeting with them, then they pushed back this technology and products without any doubt and any problem. They want to make a big stride. Now we come to some main factors affecting biogas development in some developing countries. We can, in keywords, we can say it is a high cost, low skill, and less subsidy, which inhibited the biogas development in most of the developing countries. In detail, we can say the lack of institutional and financial structure, a lack of the government long-term policy taking biogas as a part, because the Chinese government put biogas since 2005. Chinese government put biogas as the second place in rural infrastructure system. Before 2005, the rural infrastructure is road, water, electricity, and communication. That's the 4 parts. But since 2005, then biogas was added as the second part. So then after that, our Prime Minister said, rural infrastructure should be road, biogas, electricity, water, and communication. So that is much different than Chinese biogas development. Go very, very fastly. Until now, about more than 14 billion domestic biogas plants in China. Every year, about 10 to 15% increase. That is the policy. Then we come to science and technology. If policy is there, but you are lacking of science and technology, that will not put the biogas going further. So we first say, making of government a long-term national strategic and implementing policy, integrated with renewable energy, environmental, natural resources, sanitation, agriculture, and economic development. Together, then the government should have a long-term policy. Look, I would like to ask you, Thailand government last year, I received a delegation from Thailand, the energy sector. Some of your professors, like Dr. Chachela, who are in the group, to inspect, you visit the Sichuan, some of the Sichuan renewable energy, including biogas. So this is a policy from government. Then we come to science and technology. So biogas program with import of Chinese biogas equipment and experts based on the number of pilot biogas plants in the fields of household plants, decentralized wastewater treatment system, and animal farms, as well as industrial plants. So I think this part as a foundation, but government policy to guarantee the development in financing and in some system production or taxation or land taking in this case. But science and technology is a very key in this sector also. Then comes to how to make it sustainable. That depends on a number of enterprises. If without enterprises, even private enterprises, for manufacture and for engineering, for manufacture, for equipment, like this time I bring some owners of manufacture. And also for construction, for design and construction. Then for management.